Welcome back. So today we are going to be focusing on prisms and cylinders. Prisms and cylinders. So the first thing that we're going to do is we're going to take a look at some different pictures here and we're going to be labeling some different pieces on them. So when we're looking at our prisms, we have this first one, the picture we have, this is considered a right prism, and then we have what's called an oblique. Well, the difference between a right and an oblique, you'll notice a right prism, we have these nice right angles, whereas an oblique, we do not have right angles. It's kind of like he's tipping over just a little bit. He's slanted. Okay, so that's the first thing that I want you to notice here. The next thing is we're going to be labeling some different pieces. So when I'm looking at my first prism here, the right prism, we have two bases. So I'm going to label those. So this is a base and this is a base. And I realize I have to write kind of small, so just bear with me here. If we look at the oblique, we also have two bases. The next thing that we're going to be labeling is our lateral faces. So we actually have 4 lateral faces on each. So I'm just going to kind of point an arrow to each of them, trying to get as best I can. Lateral faces. There's actually 4 of them. We also have a front and a back here, but it's kind of hard to show the front and the back of that one. Same thing over here. We have our lateral faces. And I'm going to put here, there's actually 4 of them, and there's 2 bases. So then our lateral edges. What is a lateral edge? Well, that's this line right here where our faces connect. So this is a lateral edge. So I'm not going to label all of those, but we'll label a few of them. So that's also a lateral edge there. So then another one is our altitude. So altitude, so the distance from the top to the bottom, it's perpendicular here. I'm going to turn this to the side, altitude. So we can do the same thing here if we want to come straight down and be perpendicular with our bases. That would be our altitude. Again, I'm going to turn that. Altitude. Okay, so we have the altitude there. And then we're going to be writing some formulas. So the formula for our right prism and our oblique prism, the nice thing about them is they're the exact same thing. So if you remember when we were talking about area for a rectangle, we were finding length times width. And when it was a parallelogram, it was base times height. Well, we're going to find the area of whatever base we have. It could be a rectangle, it could be a triangle, it could be an octagon or a hexagon. So we're going to find the area of the base. So we're going to use a capital B, and this means area of base. Okay, that's what that capital B stands for. And then we're going to multiply it by h, which is our height. Okay, so that's going to give us our volume for both our right and our oblique. Okay, nice that they're both the exact same thing. Okay, so then moving on to our cylinder. So for our cylinder, we have bases. Again, we have a base here and a base here and 2 bases on the oblique. Same thing with our oblique. The only difference is he's slanted. We have our altitudes labeled on here for us, and then we have our radius is this little r down here for us. So then we're going to focus on our formula, and again, it's the exact same formula. But this time, instead of just writing capital B times h, we know that it's always going to be a circle, so we're going to use our circle formula, pi r squared times rh. And that's just because, like I said, we know that every base for a cylinder is going to be a circle, so this formula will work for all cylinders. Okay. All right, so then we're going to move down here to this next piece. How do we name a prism? Well, we name it by the base, by the shape of the base. Okay, and then how do we name our cylinders? Well, I'm actually going to write across both of these. I'm going to put oblique, bases are perpendicular to each other. Sorry about that. I was thinking about the right one. So bases are not perpendicular to each other. So right bases are perpendicular to each other. So remember with the oblique, they're shifted off a little bit. So bases are not perpendicular to each other. So I'm just going to put over here slanted so that it helps you to remember. So that's slanted. Whereas bases are perpendicular to each other when it's a right. Okay. All right, great job with that. So then the next piece that we have is these foldables. So you should have pinks and greens. Greens are our obliques, pinks are our rights. So we're going to go ahead and work on those. So we're going to start, sorry there. So we're going to start with our cylinders. So our right cylinder, the first thing that we're going to do here is we're going to draw a picture. Connect, draw our center with our radius, and I'm going to label my height as being 5 centimeters, and my radius is 2 centimeters. Okay, so now we're going to be using those formulas that we just talked about. So V equals pi r squared h. So we're going to leave pi in there. My r is my radius, so that's going to be 2 squared. My h is 5. So then on my calculator, I'm going to do two different things. I'm going to write my answer in terms of pi, so that means pi is going to be in my answer. And then the second one is going to be a decimal approximation. So I'm going to take 2 squared times my 5, and we end up with 20. So the first one, V equals 20 pi, and then this is centimeters cubed is my label. Or V is approximately, now we're going to take that 20 times pi using the pi button, and we get 62, and we're going to go 2 decimal places, so we're going to have 83 centimeters cubed. Okay, so that's an example of using our volume formula there. So let's go down to the oblique now. So this time, we're going to make an oblique. So we're going to slide him off to the side just a little bit here. And this is going to be a 60-degree angle here. And we'll put my radius is 4 inches. 4 inches there. All right, so volume equals pi r squared h again. This time, my r is 4, so 4 squared. But my h, it didn't give me my h. Let's call this, let's go with, apologize here, let's do 12 on this slanted side. So if this is a 60-degree angle here, we have a 30, 60, 90 triangle going on. So that means, I'm just going to draw my triangle off here to the side. So if this is 60, we have 12 here. So that means this piece has to be 6. So then this is 6 square root of 3. So this becomes 6 square root of 3. Okay, so for this one, we're probably not going to get an exact answer going on here, but we're going to go ahead and type that in. So we're going to go 4 squared times 6 square root of 3. And I get a decimal of 166.2768 something, something, something. I'm going to go ahead and take that times my pi, because I'm going to have to round my answer anyway. And I get 522.37 if we round it to 2 places. So V is approximately 522.37 inches cubed. Okay, great job there. So let's go ahead and go on to our prisms. So for our prisms, we're going to start with our right prism. So I'm going to draw my right prism. I'm drawing a rectangular right prism. So on my dimensions, I'm going to have, let's go with a 5 centimeters, a 2 centimeters, and a 6 centimeters. So volume equals area of the base times the height. Well, for a rectangle, our base happens to be length times width. I'm just going to write that here, times our height. So V equals 2 times 5 times 6. 2 times 5 times 6 gives us 60. So volume equals 60 centimeters cubed. It really doesn't matter which dimension you assign to length, width, and height, as long as you're using all 3 of them, since we're multiplying everything. All right, let's go on to another prism. So for this one, I'm going to do a triangular prism. Connect them. So for this one, I'm going to say 10 inches. Let's go 4 inches and 8 inches. Okay, so our formula again, we have V equals capital B times H. Now this time my capital B is a triangle, so that's 1/2 little b times H, okay, times, and then we have another H. So I know this one gets a little bit confusing, but we're going to look at our triangle first. So ignore the rest of it. We're just going to do the triangle. So we have volume equals 1/2. My base and height are my 8 and 4 times 8 times 4. Now we want, this is of the prism. Okay, and that's my 10. So that's where that goes. So volume equals, we're going to take 1/2 times 8 times 4 times the 10. And we get 160 inches cubed. Okay, so there's a couple different examples of using these different formulas. So now you can work on some of the practice problems. The last thing that I do want to say here is I'm going to talk about the volume of similar solids. So volume of one solid over the volume of a second solid equals scale factor cubed. Scale factor cubed. Sorry about that. Let me turn that for you. So volume of similar solids. So volume of one over volume of the second equals the scale factor cubed. And we're going to take a quick look at an example of that. So we have an example here. So if we're looking at this first one, so we have the volume of one is 4608 over the volume, we'll call this one volume T, this one's volume 1, so volume 2 equals my scale factor. So scale factor, since we went 1 on top, we're going to go radius of 1 is 12 over radius of 2 is 15, and it's cubed. Okay, so it's our scale factor cubed. So then what happens here is I'm going to cube the 12 and cube the 15. So 12 cubed. So we've got 4608 over V2 equals 12 cubed is 1,728 over, and I'll actually show you on the calculator here. So if you're not sure how to cube something, usually you have this little, it's called a caret button. And that's what we hit to cube something. So to do 15 cubed, I'm going to type in 15, that little caret button, and then a 3, and I hit enter, and that's how I get my answer for that one. So 3375. Now I can cross multiply. So I'll have 1728 times V to the V2 equals 4608 times 3375. And so now we have our proportion, we just cross multiply, and then you can solve for V2 from there. Okay, so that's what those look like. All right, that is all that I have for you today. Like I said, you'll need to be working on your practice problems, and I'll see you again later. Have a great day. Bye.